A 3D printer looks simple. Plastic goes in, a part comes out. But inside, it's a tightly coordinated system of mechanics, electronics, thermodynamics, and software working in real time. Welcome back to Clone Print Lab. In this video, I'll explain exactly how an FDM 3D printer works, step by step. If you understand how a 3D printer actually works, calibration, troubleshooting, and upgrades suddenly make sense. So instead of memorizing settings, you'll understand cause and effect. Let's start from the beginning. The big picture. What an FDM printer does. At its core, an FDM printer does three things: melts plastic, moves a nozzle precisely in space, deposits material layer by layer. Each layer is a 2D shape. Stacked together, they form a 3D object. Everything else in the printer exists to support these three actions. From digital model to machine instructions. It starts with a 3D model, usually an STL file. That file is processed by a slicer: Cura, Prusa slicer, Orca slicer. The slicer cuts the model into layers, calculates toolpaths, converts everything into G-code. G-code is a list of precise commands: move here, heat this, extrude this much. The printer does not understand shapes, it only understands instructions. Motion system, how the printer moves. Motion is handled by stepper motors, belts or lead screws, linear rails or rods. Each motor moves in tiny, discrete steps. The firmware converts G-code distances into motor steps. Accuracy depends on mechanical alignment, belt tension, steps per millimeter calibration. This is why mechanical setup matters so much. Extrusion system, how plastic is pushed. The extruder's job is simple in theory: push filament at a controlled rate. In practice, it must overcome friction, back pressure, melt resistance. The extruder motor feeds filament into the hot end, where plastic transitions from solid to viscous fluid. This transition zone is critical to print quality. Hot end and nozzle, melting plastic and shaping plastic. The hot end contains a heater cartridge, temperature sensor, heat break, and nozzle. Its job is to melt plastic consistently, prevent heat from creeping upward. The nozzle controls line width, flow shape, surface detail. This is where thermodynamics meets precision machining. Bed and adhesion, supporting the print. The print bed supports the first layer, controls adhesion, and influences warping. Heated beds reduce thermal stress as plastic cools and contracts. If the first layer fails, nothing above it matters. Electronics and firmware, the brain. The control board interprets G-code, coordinates motors, regulates temperatures. Firmware, usually Marlin, enforces safety limits, controls acceleration and jerk, manages timing and synchronization. This is a real-time control system, not simple automation. Sensors and feedback. Modern printers may include end stops, bed leveling sensors, temperature feedback. These provide limited feedback, but most FDM printers are still open-loop systems. That's why calibration is essential. Why prints fail? Most failures come from misunderstanding how systems interact, fixing symptoms instead of causes. Understanding the process lets you diagnose logically: mechanical issue, thermal issue, extrusion issue, software issue. A 3D printer isn't magic. It's a predictable machine. Once you understand how it works, you stop guessing and start engineering. To see next videos, please like and subscribe to our channel, Clone Print Lab.